Hey guys, I'm going to show you how to make SeaPerch real-time, the best hack or add-on for the SeaPerch platform yet. It'll allow you to suck up stuff like this. Ew! Now what's so cool about SeaPerch real-time is that you can take samples in the bottom of a pond or a body of water and send them up to the top without having to resurface. In this video I'm actually going to show you how to make it.
For this project you will need these materials and these tools. Now a little into the nature of pumps. The pump used in this application is a smart pond fountain pump rated for about 155 gallons per hour. Now it's not rated for anything other than water, but I just wanted to show you how you could do this for your specific application. Now this pump is a positive displacement pump, and it works by using a rotor to move small packets of liquid up the output pipe, as can be seen in this picture. And now a pump needs to overcome both gravity of the flow and friction in the tubing. And this friction is determined by the surface roughness of the tubing and by the Reynolds number of the flow. Now the Reynolds number is a very common non-dimensional parameter associated with fluid flows. And it's essentially the velocity of the flow times the diameter of the flow area over the dynamic viscosity of the liquid. For application, this will pretty much always be water. And our friction factor will essentially be 0 since we're using plastic tubing. I'll show you a little bit here how to find that frictional factor, but for further information on how to size a pump for your specific application, please consult the information in the About section. Once we've found our Reynolds number, we come here to the Moody diagram. For application, our surface roughness ratio over the diameter is 0, and that's associated with this leftmost line right here. Now when we have a Reynolds number, we plot our Reynolds number along the x-axis. So let's say our Reynolds number is 2 times 10 to the 5th. You come here and then we go up until we reach our surface roughness ratio. Then to find the frictional factor, we move to the left. Here we can see that our frictional factor is about 1.6. Now this frictional factor will change depending on the Reynolds number of your flow.
First off, you need a pump, submersible pump. Depending on your application, that's going to change the size and the power of your pump. We're going to need some weather stripping, so this is just door weather stripping, only about 6 inches of it. Let's see, we've got a waterproof extension cable here, about 50 feet. This is an AC to DC converter, so you can power it off of DC. So you're going to need some super glue, some waterproof caulk, some zip ties to fasten it on there, and for this application I use a paint stirrer, but you just need something to fix your pump onto and fix it onto the SeaPerch. Any rod or PVC pipe will do. Now let's move over to the materials. Also, this is a soldering gun, with solder of course. This is a heat shrink gun with heat shrink, and this is a caulking gun. There's a lot of guns used in this project. Let's see, so you're going to need some wire cutters, some wire strippers, and some scissors. We'll also going to need, of course, a screwdriver, and that's it. So start out with your sump pump, and this is a smart pond sump pump. What you're going to need to do is you're going to need to kind of direct the intake. So there's a couple of slots here and here that we're going to cover up with some electrical tape. See that here. And then for this side, this is where the main intake is. We're going to kind of cover these things on the side here with this door weather sealant. It kind of does 2 things. It directs the flow, but it also gives a little bit of cushion to the pump because it's going to be, kind of dragging on the bottom of the pond. Alright, so next step is we're going to make this cable longer by essentially connecting this waterproof cable to the cable of the sump pump. To do that, we're going to solder these 3 connections onto the 3 connections of that wire, and it requires a little bit of planning. Because after we're going to solder them, we're going to heat shrink them. So each one of these is going to be shrunked onto the end of that, provide a really good connection. And then we're going to shrink this onto all 3 of those connections. So you need to plan out the sizes of your cables. Just kind of make sure that you can fit your cable into this, right? Because the next step is you need to put this onto your wire and leave it there before you solder connections. Very important step. So. So for the next step, we're going to waterproof this. And so we're going to be using, this is actually, I think for gutter, it's a sealer, waterproof sealer. So you're going to need to get that, some caulk and this gun. Okay, here we go. So you're going to want to cover probably up to about here and here completely with this sealer. And don't be afraid, lay it on nice and thick. Alright, so at this point, we're just going to test out and make sure that the connection that we just made works. Right? So let's make sure that our hose is going into the sink, because that would be bad. Alright, we'll sink this bad boy down in here. Oh, didn't see that. I should. Okay, if you just want to come over here, let's take a look, and there you go. It works. So for the last part, you need to figure out how to attach it to the SeaPerch. It's really simple. You can use a rod. You can use any sort of rod. I'm going to use this wooden paint stirrer. And you're going to super glue it to the bottom of your pump like so. Right? So that when it's oriented like this, with the pump facing down, you can zip tie it here and here to the SeaPerch here and here. Alright, that's it. Thanks for watching. Feel free to leave me any feedback or comments down below.